Okay, we're doing part 2 of section 4.4, exponential and logarithmic equations. This is where things stop being so nice and clean and they get a little messy and weird, and gonna be a good time. Here we go. The nice and clean aspect of all of the examples we covered in the first part of this video series is that we could often, or every time, we were able to express both sides of the equation as powers of the same base. So we could turn when we had 64s and 16s, we could turn them both into 4s. When we had 8s and 4s, we could turn those into 2s. 5 and 125, we can turn those all into 125s. We're going to run into problems when we don't have questions that are designed to be nice. So it's possible that we're going to get questions with weird numbers that aren't really powers of anything, like 23 to the x plus 1 equals 57. I'm just making up numbers here. 23 is not a nice, easy power of some number. 57 is not. In fact, I think both of them are prime. They're not even multiples of numbers, let alone powers of numbers. So the question then becomes, what can we do with this? And the answer is, we're going to take the natural log of both. How did this get twisted? We're going to take the natural log of both sides. Why the natural log? Just because it's sort of like the default log. So I'm going to do the natural log of 23 to the x plus 1 equals the natural log of 57. How does this help us? Doesn't that just make it look more messy? We took an exponential equation and now there's logs involved as well. Here's how this helps us, and here's why the natural log is very powerful. In section 4.3 we talked about the properties of logs. And one of the properties that we talked about a lot was that an exponent inside of a log can be sort of extracted and brought down in front as coefficient multiplication. And that's what we're going to do with this exponent. So we're going to say x plus 1 goes in front. Once we pull that out, we have the natural log of 23, and it equals the natural log of 57. At first glance, this doesn't look much better. This looks like all the same pieces, just in different places. Here's why this is much, much better. Here, our exponent is, or our variable is sort of trapped inside this exponent. And as long as it's up there, we can't really do anything to it. Like, there's no way you can, like, if we want to get x by itself, at some point it should be clear that we're going to have to subtract 1 from both sides. But you can't subtract 1 from this exponent and then 1 from this exponent, or 1 from this number. That doesn't make sense. There's nothing we can do to both sides that will affect this exponent directly. But once we bring it down as a coefficient, now we have access to it. Now we can do things to both sides of this equation to start isolating this x. And the first thing we need to do to isolate this x is get rid of this, which looks messy, but it's just a number. I don't know what number it is. It's probably 4 and change maybe, or 3 and change, I don't know. Honestly, I have no idea what this number is. You could plug it into a calculator to find out if you wanted. It's going to be a weird decimal. But the cool thing is that it doesn't matter what it is. I don't need to know what value this has. All I need to know is that it's a number, and it behaves like a number, which means I can divide both sides of this equation by this number. And it'll cancel. And now I just have x plus 1. I'm much closer to isolating x now on the left than I was before. Here we have the natural log of 57 divided by the natural log of 23. When you see stuff like this on tests or homeworks or quizzes, it's going to be very tempting to try and simplify this. Don't. Natural log doesn't cancel here. You can't combine this into the natural log of 57 over 23. There's no simplification for this thing. Just leave it alone. It's just ln 57 over ln 23, and that's it. That's all you can do. But the good news is we're only one step away from isolating x and getting this thing solved. We just have to subtract 1 from both sides, and I do not have enough room to do that down here, so we'll come over here for it. X equals ln 57 over ln 23 minus 1. And some of you might be thinking, that's not a solution. I have no idea what number that is. And my response is, it is a solution because x is isolated. I don't care what number this is. It's a number. I promise. So, this is your solution to this problem. If 23 to the x plus 1 equals 57, then I know that x is ln 57 over ln 23 minus 1. So this is the kind of weird stuff we're going to get into when we cannot express both sides of this equation using powers of the same base. So I'm going to do another one of these to see what it looks like when it gets even worse than this, and then we'll move on to other topics. Okay. Let's do 11 to the 3x minus 8 equals 45. We're going to follow pretty much the exact same procedure we did in the last one. Step 1, we're going to take the natural log of both sides. I'm going to do it, I'll do it here. Natural log of 11 to the 3x minus 8 equals the natural log of 45. Because this thing is now in a log, I can use properties of logs to extract the exponent. Say 3x minus 8 times the natural log of 11 equals the natural log of 45. I don't know what the natural log of 11 is, but I know it's just a number, so I can divide by that. Cancels there. 3x minus 8 equals ln 45 over ln 11. Again, it's tempting to want to simplify this somehow. Do not. It does not simplify. There's no easier way to express this value. It's just ln 45 over ln 11. Then we add 8 to both sides and we get 3x equals ln 45 over ln 11 plus 8. And then we divide by 3 and we're done. I should mention that at this point right here, this step is where we have transformed this into a linear equation. And it doesn't look linear because it's got natural logs involved, but they're not the natural logs of variables. Natural logs of variables count as weird stuff. Natural log of 11 is just a number. Natural log of 45 is just a number. That's not weird. Those are just numbers. So this is a linear equation. We have a value, a variable, getting multiplied by some real numbers, getting added or subtracted by some real numbers. We got other numbers involved. So that's where it becomes linear. And then we solve it like normal. X equals ln 45 over ln 11 plus 8 all divided by 3. And again, do not simplify this. It doesn't simplify any more than this. It doesn't saying that this thing is fully simplified feels bizarre because this is the opposite of simple. This is a mess, but it really is as simple as it gets. There is no simpler way to express this number, so it's fully simplified. Don't try to do anything else to it. Okay, what's next? I think that about covers exponential equations. That's about as bad as they get. We're at 11 minutes already, so I'm going to cut this one here, and I'll be back in part 3 for some logarithmic equations.